Okay, dear students, it would be a long holidays for you, but before that, I want you to complete this numerical because there would be an assignment over it. I mean, you will have to resolve it. It's very easy. I've developed the flexibility matrix for this frame, 3D frame. Actually, I've changed the frame. The flexibility matrix is actually independent of loading, so I have just changed the loading. In the previous lecture you could see that the load was applied here, and the distance was 7.5 and 7.5 feet and 7.5 feet. The load was same, that is 10 kip, but I thought while solving the question I thought it would be a bit difficult for you because sectioning would be changed. So it's better to apply load at the corner or at the support. So I have just changed the load. So flexibility matrix would remain the same. However, in the flexibility matrix, there are a few terms that were missing. While solving the question, I realized that a few of the terms, for example, F46 or F56, I did not calculate. So you can go through that lecture and you can develop. There are a few terms that are missing. For example, there might be F45 or F54 or something like this. There are no F45 or F54, so you can easily solve that. Make sure that you compute all 36 entities, and obviously many of those would be zero, but you will have to calculate those 36 values. Okay, next I have to calculate the DRL matrix. DRL matrix is actually displacement in release structure due to applied loading. So flexibility matrix have been developed, and this is the frame, and I have to the frame is obviously, I have to change this. Okay, this is your frame, and frame, the SI is 6 degree, and it was made determinate by removing these two hinge supports. I could have removed this as well, but this would be no good for structure, because structure would be rendered unstable, because this support is capable of taking all the moments and torsions. So that's why it's better to keep this support, and it's always a good option to remove these two hinge supports to make the structure determinate. Okay, next I've made the structure determinate by removing the two hinge supports, and all the 6 redundant actions have been identified, and applying one by one, applying the redundant actions one by one, I developed the moment table. I constructed the moment table, and by multiplying respective moment table, the respective values in corresponding moment table, I was able to generate flexibility matrix. However, this step was missing, and this should be foremost step before this step should come before the flexibility development of flexibility matrix. For example, you are applying the redundant actions one by one, so you should calculate the response of a structure under the applied load, because you can recall from 2D beam. First of all, you made structure, basic determinate structure, then you develop DRL matrix, then flexibility matrix. So before applying the unit redundant actions, applying the one by one reaction, I can calculate the response of a structure, and I can construct the moment values. Okay, before that I have to develop the free body diagrams. Okay, this structure it's always a good option to start from a free end. So 10 kip is applied here, so I can apply a 10 kip that would be equal and opposite. It is in Z direction, so it is also in Z direction. This 10 kip, moving this 10 kip towards support O, point O, joint O, will develop or render moment of 150 kip foot anti-clockwise. 10 into 15 gives us 150, and that would be anti-clockwise. So I have to apply a resistive moment, that is clockwise 150 kip foot. You should know that this is anti-clockwise in Y, this is anti-clockwise in Z, this is anti-clockwise in x direction. So analyzing this frame of reference, I realized that this is 150 kip foot in x direction, and that is positive because this is forming an anti-clockwise moment. So this is clockwise. Okay, balancing 150 kip foot with equal and opposite 150 kip foot, and similarly this 150 kip foot torsion would be taken by support as it is, because this member is along x-axis and this moment is along x-axis as well. So this is torsion for this member. This 10 kip has to be balanced somewhere at joint O. It cannot be balanced here. I cannot apply 10 kip here due to this 10 kip because there is no support here. I've made it basic determinate, or I have made it determinate structure by removing these two supports. So this 10 kip would be taken by this joint O of section CO. Then 10 kip would be balanced here as 10 kip. Okay, next the load on this structure, load on this member's CO is there's a UDL load 2 into 20. 2 into 20 gives 40 kips. So I have to apply equal and opposite 40 kip upwards. Okay, next. This 10 kip is in Z direction and this is in X direction. So there would be a moment in Y. Z and X, Z. The load is in Z. The member is in X. So there would be a moment in Y. Okay, moving this 10 kip towards C, it forms an anti-clockwise movement. So that would be balanced by equal and opposite resistive moment. 10 into 20, 200 kip foot. It is forming an anti-clockwise, so I'll apply a clockwise moment. You should know that this is an anti-clockwise moment in Y. This is counterclockwise. So this is a clockwise moment. You can use the right hand rule. So imagine your hand and curl it. Point your thumb towards these arrows and look at the curl of your fingers. It would be clockwise. So this is 200 kip foot clockwise. That's why it's plus. But it's always good not to write any plus minus sign because you would be confused. It's always good to write plus minus signs here. Okay, next. The moment due to this 10 kip foot load have been mentioned here, and this load has been balanced as well. Next we have this UDL, because this UDL can form a moment as well. So for example, this UDL 2 kip foot is in Y direction because it is acting downwards from Y, and this member is in X direction. So there would be a moment in Z direction. So the magnitude of moment, because 2 is acting at 20 feet, 2 into 20, and again at the midpoint, you have to find the moments at the midpoint. So 20 into half of the 20 gives us 10. So 2 into 20 gives us 40, and 40 into 10 gives us 400. But this is upward, this is acting downward, and moving this toward the support gives us a clockwise moment. So I have to apply resistive moment. That would be anti-clockwise in Z direction. So this is 400 kip foot in Z direction because this is counterclockwise in Z. So you can point your thumb here and look at the curve. These are all anti-clockwise moment. This is in Y and this is in X direction. So I've been able to construct the free body diagram, and next we have to construct a moment table. If any other moment is missing, you can do it on your own. The sectioning is very easy and very important point of this flexibility matrix, a flexibility method you had been doing in your BSc. Because this member has no loading, so one section would be enough. You know that this is C. So I have taken this section BO. It's always good to take section or take origin at supports. Again, if I consider this section, you will notice that the applied load is here. So I think this section would be enough. There is no change in loading. This is resistive, so no need. There is no applied load throughout the structure, throughout the member. So one section would be enough as well. So this would be AO. Finally, this member, the origin is for example C, because there is a UDL load. You can see the original structure. Okay. Because there is no loading, so one section is enough. Here, starting from A, there is only one applied load, so one section would be enough as well, and this would be Y. Starting from the support and taking this as section, you can see that there is a uniform loading and the magnitude of the loading is not being changed, so that's why one section would be enough as well. Okay, finally, starting from section BO, no activity here, so all the values would be 0 here as shown here. From AO perspective, you can see the origin is A and you know this is Y. You have to find all the moments here. This section has been named Y. You know this is forming an anti-clockwise moment, 10Y, so this would be balanced by a clockwise 10Y, and you know this is in Z direction, this member is in Y, so this should be in clockwise X, so it would be coming under MX. I have mentioned all the moments due to applied loading in capital letters, whereas when unit redundant actions were applied, all the notations were in small letters. So this is also a major difference between these two. Okay, so this has been done. Next, the section is X and I have to find all the moments here. This point, you know, at the left is 150 kip foot and this is anti-clockwise in X, so it has to be balanced with the equal and opposite torsion TX, and this would be negative because this is anti-clockwise. You should know that this is an anti-clockwise in X, so this is 150 pure moment, so it has been mentioned as it is. Next we have this 10 kip, and this 10 kip is in Z direction, this member is in X, so the moment would be in Y. This moving this towards this point, you will get an anti-clockwise moment. 10 into X, it should be balanced with a clockwise. This is in Z and this is an X, so there would be a 10X in Y. This is in Z and this member section is in X, so I have mentioned a 10X in MY. Also, we have this pure moment 200 kip foot. This is in Y direction and this is applied at support, so this would be resisted here at this point with equal and opposite 200 kip foot. You should know that this is clockwise and this is anti-clockwise, so I have mentioned minus 200. Again, now coming on to this 400 kip foot moment, this is in Z direction and this is anti-clockwise. It should be balanced with a clockwise in Z direction at this point, so that would be 400 kip foot, and you should know that this is now clockwise, this is anti-clockwise. Okay, it should be written here in MC because this is applied in Z direction. Okay, also this loading is in Y direction 2. 2 kip foot is acting on x, 2x in y. This is applied in y direction, and the section is in x direction. So there would be a moment in z as well. So 2x into x by 2, x square. 2x into x by 2, because it is acting in y and this is an x, so there would be a moment in z. You should know that it is acting downwards. The section is like this. This is x, and the loading is applied like this. So moving this load towards this section will gives you an anti-clockwise moment. So it was balanced by a clockwise, x square. And finally I have this 40 kip, 40 moving this is in y, this member is in x, y, x gives you z. Moving this 40 kip towards this point gives you plus 40x in z. It has to be balanced with minus 40 because it is forming a clockwise. So I have applied a minus 40 kicks. In this way, all the entities in this moment table have been identified. Okay, next step is, now once you are done with this, you have to multiply all these values with respective AR values. Like for example, you have to calculate the DRL matrix and DRL1, first entity of DRL matrix. Then you will have to multiply this table with this one because this is AR1. In order to develop DRL2, you will have to multiply this is DRL2. In order to get this DRL2, you will have to multiply this with these values. Similarly, moving on, for DRL6, you will have to multiply these table values with DRL here. Okay, in this way, following this approach, I've been able to develop all the values here: DRL1, DRL2, DRL3. So for example, I'm going random. For example, I want to go random, so I'll calculate DRL3. It's very easy. I have this DRL3. For DRL3, I'll have to look into this table, and I realize that I have this value at mx and these three values for section CO. For section AO, I have one value. For section CO, I have three values, and mx, my, mz, mz, top four values. Okay, and I have to multiply it with AR3, the table constructed for AR3. This is AR3. I realize that there is mx here and there is mx here as well. So this 10y would be multiplied with y. Again, here I have my and tx, and here I have my and tx. For this value, I have 0 there. So there would be 3 multiplications. 10y will be multiplying y with y, 150 would be multiplied with 15, and so on. So I have 3 values corresponding to these 3 values in AR3 table. So it's very easy. So I've done it here, this 1 value, 2 value, and the 3rd value. Obviously this belongs to section AO, and for section AO has the length of 15 feet. Yes, section AO has 15 feet. So the limits should be properly mentioned here. Also, these 2 values belong to section CO, that is the length of section is 20. So that's why 2020 is mentioned here. I've solved it using calculator. You can use online calculators. You have got simple calculators. It should never be done by hand because it is quite prone to errors, because you will be facing it's the approach because the calculations are quite tedious, so you cannot do it using hand, and it's also a wastage of time. It's always better to use online calculator. You can use Excel as well, or you can have a calculator. 3x3 the normal calculators that is worth rupees 400-500 can solve these integrals. Okay, this is the answer. Okay, going random, and for example I want to calculate DRL6. So for DRL6 I have to go to DRL AR6 this, and I realize that there is a MX here for section BO there, and going back for DRL matrix I have nothing here. It means 0. Also I have got some value here, that is 10y, but all values are 0 there. Okay, I'm safe. Next I have this minus 30 in the section CO and x minus 20. One is tx and mz, and I have some values here, mz and minus 150. So minus 150 would be multiplied there, and this value would be multiplied there. For these two values, this and this, I have 0 corresponding values. So I have done some calculations here. This one, there might be some error because I'm human, so I might have done some few mistakes. I don't think so, but I have I realized that I have done it very carefully, and I mean it took me quite a few time to solve this. But okay, one thing should be noticed, that this is very important point. I just remember that this is torsion minus 150, and for DAR6 I have a torsion as well. So when you are multiplying these two torsions, so you have the formula when torsion multiply with the torsion, and for example it may be dx, dy or dz, it should be divided by 0.8 of EI. So that's why I have written 0.8 EI, and solving that I have got this value. I don't want to go into that, it's very easy. And finally, going random, let me solve DRL4. Okay, for DRL4 I'll have to go here. I was random, so it's my luck that I've got only one value. So this my I have got 20 minus x, and corresponding value, it's in section CO and it's under the heading my. So I'll have to go back here. So for section CO I have got this. It should be multiplied with this value. Both are my. One is capital My and another is small my. So DRL4 have been developed here. It's very easy. The length of the section is 20 feet, so I've solved it. So once this DRL matrix should be, values should be written like this: DRL1, DRL2, and you will go up to 1, 2, 3, 4, 5 and DRL6, and you have to multiply with n inverse, and you should know the order of this matrix is 6 cross 6. You will have to use the Excel sheet. You may use calculator, you may use online calculators, but it's always best to use Excel sheet. So when you multiply, the order here is 6 into 1. So these two can be multiplied. You will get an AR value. So this is your task. After each, you have to submit this question. Exactly the same question. So I'll check it. I mean, you have to calculate the AR, AML, and again using the other mathematical models, you should be able to calculate AM matrix, AML matrices. So this is very easy. using the same basic approach, how to that is how to solve a beam or simple frame or flexibility matrix. You should know that you should identify you will the redundant actions, make it determinate. Then you have to develop the DRL matrix, then flexibility matrix. Then using the first mathematical model, you will calculate AR matrix, AM, AML, and finally shear force bending moment diagram. So this would be quite the shear force and bending moment diagrams for 3D structure is quite difficult. So you cannot draw it using your manually, but you can do it using SAP. But there is no need. Just learn this method and solve this numerical, and this would be your assignment. Thank you very much.